Now let's see if our model created, how accurate it is. To find the accuracy, we are using confusion matrix from caret package. So first we give the name of the column that we use, that is the actual data set we had. In this test set, the survived, then and the predicted values. So you can see the accuracy of this model is 78%. It is 78% accuracy of this model that we created. So there is some of the errors that occurred. So you can always create new models using by removing or adding different variables to your model. This accuracy will improve. Now let's create a regression tree. So for regression tree, what is a regression tree? It is created for continuous variable where the responses is quantitative. This was our data set that we are using. Now, as a continuous variable, what we will be predicting is, we will be predicting the age of a person based upon the other variables present in this data set. For that, the method that we use is ANOVA. You can what we can do is, we can split the data set again and then create the model. It will give you a better accuracy. But right now I am taking the whole data set here and creating the model. The method that I'm using is ANOVA because it is a regression tree and we are predicting a continuous value here. So using rpart, the dependent variable based upon all other factors. So let's check this model and plot it. So you can see now what is the difference between the earlier graph and this graph. Here in the other graph, the ones that we created for classification tree, so you can see there is 100% of the population taken here. In the first node, 100% of the data has been taken, out of which, so our 100% data here taken as 1046. So it has taken the training data set here. So some of the, it says 263 observations deleted due to missingness. So they were the values were NA there. So therefore the values have not been taken. The number has been reduced to 1046. Out of this 1046, that is the root node, the average age of the person is 30. So it is giving you the average age of a person in that data set. So first we are taking it for 100%, that is entire population. So average age is 30. Next, the first split is based upon the passenger class, if it is equal to second or third. If yes, then the average age. So this 100% has been splitted into 73 and 27%, out of which 73 if the passenger class is second and third, the average age is 26, otherwise it is 39. Then if it is 39, it is also divided further based upon the parent or children numbers. If they are greater than or equal to 2, then it is 41 age. If it is less than that, the age is 28. So this is how it is predicting the age. The numbers you are seeing above your node, at the top of the nodes, they are the ages. So it gives you a quantitative response here. Next, what we are doing is, we are taking a sample out of our data sets, similarly that we used earlier, by using sample data, sample.fraction. This is the function that we are using to create some of the sample data. So earlier we used sample n, which means only the number you have specified. If I have taken sample n here and specified 3, then only 3 rows would have been selected in this variable. If I am saying fraction, it means 0.1% of the whole data set will be saved in this variable sample2. If you want to see the dimension and the head, so there are 131 rows that have been saved in this data set. Now the formula that we are using is predict, giving the model that we just created for the regression tree. I am saving it in pred age. The new data that I am applying here is sample2, that is 0.1% of the whole data. And type equal to vector means the response will be in the form of vector. Now let's see the head. So what does it mean? The first passenger here. So the average age of that person is 32.10. So you can see the actual age was 35, but it predicted 32. And the average of next person is around 54. Our model predicted 40.54. So what we will do is we will combine our two columns, that is the data set sample 2 and pred age, and let's check. So simultaneously we can check that, and we can compare the actual and the predicted age. So there is very little, some of the values are of great difference, but some of them are of nearby difference. So to check this difference, how do we check that? For that we use a package caret, and there is a function called RMSE. So RMSE is the root mean square errors or the deviations. It measures the difference between values predicted by the model and the actual values that was in our model. So the lesser the value of RMSE, the better is your prediction. So here the first part that we mention here is the actual one, the actual column that we had. So here it is age, and then the predicted age. Na.rm true means it will remove all the Na values if there is any. So it is 12.77, which means the prediction varies with a 12.77 value from the mean age that we actually had. So this is the difference that we are having, and it is the deviation or the error rate in our model. So this is how decision trees are created for classification and regression models. You can always split the data and then create model. It will always give you a better output.